8.6 is digit and coin problems, and you've probably seen problems like this before, but didn't realize that you were actually using your algebra skills for it. So we're going to be looking at how to set up equations now for these coin problems and digit problems. So we're going to use systems of equations to solve digit and coin problems. And we're going to hop right into our first example here. And in this first example, the sum of the digits of a two-digit number is 14. If the digits are reversed, the number is 36, greater than the original number. Find the original number. So the first thing that we have to look at is how can we express a two-digit number? Well, a two-digit number can be expressed as 10x plus y. So this is 10x plus y is a way to express a two-digit number because we can make x be 1, and then if we're plussing y, so we're plussing 3. So if x is 1 plus 3, we end up with 13. So this will always end up with being a two-digit number. That is that we can then reverse it by switching our x and y's, reverses our two-digit number. So if we switch x and y, that is that we end up with 10y plus x, it reverses the two-digit number. Alright, so now we need our let statement. So I'm going to let x equal the tens digit. And y equal the ones digit. So my first statement is the sum of the digits is 14. So that is x plus y is equal to 14. And I got that right here. Now my second statement says that if the digits are reversed, the number is 36 greater than the original number. So first I'm going to reverse the digits. So I'll do 10x or 10y plus x is, so I reverse the digits, is means equals 36 greater than the original. So is 36 plus what the original number would be, which was 10x plus y. Whew. Now I need to simplify my secondary equation here, and I'm going to end up with, I'm going to minus 10x and minus y, minus 10x, I end up with 9y minus 9x is equal to 36. So now I have x plus y is equal to 14, and 9, I'm going to put this in the right order, negative 9x plus 9y is equal to 36. Now notice that one of my values is negative. And with that, I'm going to multiply all of my, I'm going to multiply my top equation by 9, so that way I can cancel out my x's, and I end up with 9x plus 9y is equal to 126. And I'm just going to shift this equation plus 9y is equal to 36. The x's go away, I end up with 18y is equal to 162. And 18 divide by 18, divide by 18, and I end up with y is equal to 9. Now if y equals 9, I can go back to this original equation right here and find out x plus 9 is equal to 14, so x must equal 5. So I have the point 5, 9, otherwise known as 59 if we put it all together. A lot of work, but follow it through and you'll get to your answer. Okay, let's try this one. Cami has some nickels and some dimes. The value of the coins is $1.65. There are 12 more nickels than dimes. How many of each does Cami have? Alright, so for this one, I like to remember what I'm working with here. Nickels are 5 cents, and dimes are 10 cents. And I know that so the first equation I'm going to write is I'm going to let x equal nickels and y equal dimes. So I know x times 0.05 plus y times 0.10 is equal to $1.65. My other equation, so that's equation 1, my other equation is there are 12 more nickels, so x than dimes. So the way that I'm going to do this is x is equal to 12 plus y. So the number of dimes plus 12 is equal to y. Now I have an equation that's already solved for x, so I can plug this right into my x into the first equation. So 12 plus y times 0.5 or 0.05 is equal to plus y times 0.10 is equal to 1.65. Now I don't like dealing with all these decimals, so the other part that I could do is I can multiply everything by 12. Or not by, multiply everything by 10. But I'm going to hold off on that for a moment. I'll actually just distribute all of this. Actually, I'm going to go back and multiply this equation by 100 to move my decimal 2 places. And then I'm going to erase here. And then I'll substitute in. Because what this does then is that becomes a 5. And I have 10 here, and this becomes 165, which is going to make it a little bit easier for me to solve. So now I have 60 plus 5y plus 10y is equal to 165. I'm going to subtract that 60 from both sides and end up with 15y is equal to 105. So y is equal to 7. So I have 7 dimes. And I can go and plug that into here and have x is equal to 12 plus 7 x is equal to 19 nickels. So the little piece that I did right here is I multiplied that entire equation by 100 to move my decimal places 2 spots in every point. So that way I could work with whole numbers. Alright, last one here. There were 411 people at a play. Admissions was $5 for adults and $3.75 for children. The receipts were $1,978.75. How many adults and how many children? Alright, so for this one we can kind of set up a couple different equations. My first is I'm going to write my let statement. Let x equal adults, y equal children. Alright, so let's write an equation. X plus y must equal 111 people. Now my other information that I know is $5 for adults, $3 for children, and it should total up to $1,978.75. So 5 times the number of adults there were, plus 375 times the number of children there were, is equal to 1,978.75. Again, I don't like working with decimals. I'm going to multiply this entire thing by 100 to move that decimal place in every spot 2 spots. So this becomes 500x plus 375y is equal to 1,978.5. And again, I have my other equation, which is x plus y equals 1. So I have multiple different things that I could do here. You could do substitution, solve for x and substitute in for y, or you could do elimination. I'm going to do an elimination where I'm going to multiply this all by negative 500. And this gives me, I'll rewrite this over here, I end up with 500x plus 375y is equal to 1,978.75, and negative 500x minus 500y is equal to negative 205500. X's cancel out. I end up with negative 125y is equal to negative 7625. Divide, y is equal to 61. So we had 61 children. Go back and plug it in. X plus 61 is equal to 411. So x is equal to 350. So 350 adults, 61 children. Always set up your tables if you need to do this, but really work out your equations. We're going to do more practice on this during class.